So, hello everyone. So let's start with a question. How many of you, raise your hand, ever developed an app for Bluetooth? Oh wow, okay, great. So, or how many want to start? Want to stop? Okay, the same as the first question, great, okay. Today we will explore best practices and Kotlin code to understand how to interact with Bluetooth devices in Android. Okay, great. So we are Samuele, Damiano, and Jacopo. We are from Empatica, and our job is to build the mobile apps to connect to a medical device to collect health data. So the main takeaways from today will be about tips to master the Bluetooth in Android, write functional and testable code, and how to test and debug Bluetooth apps in real devices, and why not some snippet also from Android 12 and the latest 13. So. Before talking about Bluetooth, just quickly let me introduce Empatica. So with our focus to build medical devices, hardware and software, used to collect raw biological data and create algorithms and to monitor the health. So mobile development for us is extremely important because we consider to work at the intersection between hardware, software, data science, and it's amazing. And we are people from 23 countries, and we have an office in Milan and also Boston. And by the way, we just celebrated 100 Empaticans, so it's amazing, and I think it's the right time to join us. So, yeah, at the beginning, 2 years ago, the hardware was not so fancy. Imagine the software. Everything started from a prototype like this one, and while we were working there on this prototype, we were sitting together, mobile and firmware developers, developing the SDK. And in the end, we built a full ecosystem composed by a wearable, an SDK, and the companion app. We invested a lot in Kotlin, and we have 100% of the code base in Kotlin and the latest patterns and so on. So, and also we shared a lot of logic with the Kotlin multiplatform with the iOS part. And we already used Compose even in production. So it's, yeah, it's great. Okay, but let's start talking about Bluetooth. So quickly, let me introduce some basics because maybe someone wants to start. Is important. So to interact with the Bluetooth device, such as wearable, we need to start from the Bluetooth adapter class that is provided by Android. The Bluetooth adapter is basically the way to access the Bluetooth radio component of the smartphone. So. And the Bluetooth adapter you can get from a Bluetooth device instance that basically is the representation of the remote device. And you need to use the Bluetooth device to start the connection to send or receive packets. So to recap, the main responsibilities for the Bluetooth adapter are to scan, to find the Bluetooth devices nearby, and to get the Bluetooth device object. And yeah, oh, sorry. And from the Bluetooth device, yeah, you can perform the actual connection, getting the device information like the serial number, the firmware version, and also exchanging data. Talking about the standard, the Bluetooth standard, the organization of the information are by services and characteristics. You can imagine a service and the characteristics like variables in your code. So you can assign a value or read a value, and the main two ways of using the characteristics are you can have one characteristic for each value that your wearable may generate, like the temperature, the heart rate, everything, or you can have a characteristic used as a byte buffer. You can write inside bytes, and you need to parse data, and that's it. So it's okay. So it was easy. Okay. So let's show the code. Okay. Let's welcome Jacopo on stage. That will dive into the code.
Thank you, Samuele. Okay. So now we'll see some of the basic Bluetooth operations and going a bit more in detail and showing also some code examples. So we'll see in particular how to do a Bluetooth scan and some important things about the Bluetooth scan. and how to communicate with the device, so read and write data from it. So, starting with the scan, of course, to do a scan, we need a scanner, and that's the basic code to get it. We can set some settings, and with the start scan method, we can start the scan, passing an object that basically will receive our result. So it's a very simple interface, so we need to pass an object that implements this interface. It has one method to receive the result and one method to receive errors. A very important thing to keep in mind working with scanning is that it's a very battery intensive operation. So there are important things to remember. One is that as soon as you find the Bluetooth device you are looking for, you should stop scanning. And another one, very important, is to avoid to scan in a loop, so repeating the scan too quickly. Another important thing to remember is that, for example, if you do a long scan, and you find the device at the beginning of that scan, the device could not be available anymore at the end. So in order to be sure that it's still available, it's better to do shorter scan and also, but at the same time, you need to find the right balance, because Android has this important limitation that basically you can't start the scan more than 5 times in 30 seconds. So another important thing is that scan filter is not very reliable. So depending on the phone you are working, it cannot work the right way. So it's always better to do the scan without filtering and then do the filter later. Also remember to not connect to a device before stopping the scan. So always call the stop scan method before. So about the limitation I said before, before Android 13, basically if you went out of that limitation, it stopped worked. And silently, basically. So the good news is that from the Android 13 there is a specific error, so that you can notice it immediately. So moving to writing data to the device. Basically, you can think of the Bluetooth device as a standard server. A normal server has post and get calls, and it's more or less the same with the Bluetooth device. Basically, we can write and receive data from it, and also receive notifications from it. So imagine you need to write data to the device, and you're writing, for example, a byte array to a specific characteristic. What happens if at the same time the device sends the data to you? So through a notification, it tries to write on the same characteristic. Given we are on the same characteristic, what could happen is that Android at low level mixes the byte arrays, and we end up with a corrupted byte array. So to mitigate these, basically, here you can see the code that the code that receives the notification. One thing we can do to mitigate this, basically, is to copy the content of the characteristic as soon as possible in order to avoid this problem. But of course, it's not really reliable, and the best solution is to use an handler that we can pass to the connect method. This way we are sure that Android will write and we will write to the device in a single thread, and so we avoid this problem. Another thing that can be done to avoid it, if you have the possibility to work at the firmware, so you are working with a firmware developer, instead of using a single characteristic to read and write data, you can design a protocol that uses different characteristics, one just for read and one just for write, and this way you are completely safe and you are sure that this won't happen anyway. So, moving on, we can see now something that happened to us that required kind of advanced debugging, let's say. So we had this client that asked us to work with the specific phone model. And we can call it the cheap phone plus, because to not use the real name. Basically, this was an inexpensive phone because the client needed a lot of these phones, hundreds, so it was very important for the client. And basically, when we started working on it, we started testing it with our current app, with our SDK, and it kind of worked sometimes. It happened that with my specific phone, there were crashes, and it was very difficult to understand why. The crashing were happening in the data parsing, so we have basically a specific data format, and for some reason the data format wasn't respected sometime. So I started working into it, and the very strange thing was that the problem happened just at my home. When I went to the office to test it with a firmware developer, it stopped happening. And basically, in the end, what we found is that at home I had a 2.4 gigahertz network. In the office, there was a 5 gigahertz one. And basically, we found casually a post on a forum. This guy was saying that he had problem with this specific phone model when he was connected to a 2.4 gigahertz network with his Bluetooth headphones. And basically what we found was that when the phone was connected to a 2.4 gigahertz network, it was corrupting Bluetooth data. And yeah, I know, it was kind of strange. And yeah, because probably the point is that 2.4 gigahertz network and Bluetooth uses the same band, so probably there was like a problem at a low level driver. But anyway, what we did in that case was asking the client to disable this kind of networks on the phones. And also we added a log to monitor network types. And also we added a CRC, that basically is a standard way to verify that the data you receive is the same the firmware sent. A tool that we used to solve this problem that can be really useful is this one. Basically, you can enable this setting in the developer setting, and basically if you enable it, the device will start saving in a specific file all the Bluetooth packets received by the phone. And to find the file, you need to look for your specific phone path because it's different in basically every phone. To read easily the file produced that way, you can use the Wireshark app in order to, read it in a more natural way, because it's a very complex file. Another tool that you can use to debug Bluetooth problems, and this is really useful, you can look for Bluetooth logs produced by the OS. So if you add a filter on logcat, you can look for exactly only that Bluetooth logs. And also, every Bluetooth logs have the name of the file in the source code that generated it. And so you can also go to the source code and look into it. Because, I mean, it's quite complex, but for example, if you find a constant that represents an error that is not well documented, maybe the source code can help. Okay, now I leave the stage to Damiano. Thank you.
Okay, thank you, Jacopo. Okay, now we had an overview on the main highlights and the main struggles, of course, of working with Bluetooth in Android. So now let's have a look on the main patterns that you can find developing a Bluetooth application, and the patterns that, in our opinion, are the most used also in the whole community. I mean, in the code base we saw. So the key point, of course, is starting with abstraction, like almost everything. So in particular, abstraction over Bluetooth GET callbacks. So just to introduce something, the concept, we can have basically two approaches. We identified two approaches. The first one is the callback approach. Okay, is basically based on the Bluetooth GATT, so what we already have on Android, and it works, and is the approach that we find the most on the code base all over the community, because it's similar to the Bluetooth GATT. But maybe we can try to implement it with some cooler way, and we can use Kotlin flows, some reactive programming, and fancy stuff like that, which is always a nice point to have. So, but first, let's start with the callback approach. So, for this presentation, we designed just a solution to show you how it can work. So, basically, we start with having an interface, which is a listener, and such a listener exposes some events. In this case, we have a characteristic change event that, of course, tells you that a characteristic in the Bluetooth stack changed. And, of course, you need to use that listener, and to use that, you should base your implementation on the Bluetooth GATT callback. So here, basically, we have the onCharacteristicChange method of the Bluetooth GATT, and we basically forward the information to the outside world. So who implements that Bluetooth listener. And going to who implements that listener, we can go to our kind of implementation. We have an interactor, which is able to send commands, of course, and by implementing the listener, is also able to listen to the responses to that command that we sent. So that we receive the response, we can parse the value we receive as a byte array, we can check if actually that's the response of our command, and do some fancy stuff with it, maybe mapping and stuff like that. From a unit testing perspective, this is also convenient, because as you can see, you can emulate the events you receive from Bluetooth just by calling the onCharacteristicChange method. So once you provide your own byte array to the method, you are able to verify what your class is doing. And so you can basically test it without having the physical device, which is always a good thing to have. Then we can say that the callback approach, in our opinion, is the most used, especially in old code bases, maybe code bases that started quite long ago, but is the main approach that we find to use Bluetooth, also because of the similarities on the Bluetooth GATT. And since we are working on Android, remember that everything that starts needs to be terminated at some point, because we are handling with life cycles, activities, fragments, and all this kind of stuff, and everything has a starting point and a stop. So once you send a command, please at least design a method to stop that command, or just to dispose the fact that you are listening to the response, just to avoid memory leaks and stuff like that. And of course, don't mess too much with threading, because with Bluetooth is kind of a common topic, but just limit yourself to fill in the handler that we show you, to you before. And then if you need to dispatch something in some thread, just do it in a single place, so you don't spread the threading code all over. So now we can move actually to 2022 and talk about Kotlin flows. Yeah, it's the super API that coroutines provides us. And here we design basically a solution which is similar to the previous one, but it uses a flow to emit events. So in this case, we modeled the payload we received from Bluetooth, which is the characteristic change payload, which has the ID, of course, service ID, and the value, which is the byte array. And as you can see, in the Bluetooth events emitter, we have the characteristic change flow, which emits events. So now, if we compare it with the previous approach, now we need to implement this interface in a class that maybe is itself, let's say, extending the Bluetooth GOT callback, so that we can receive the actual system events and translate them to flows and make them reactive in some way. So as you can see, we just create the payload and we emit it through the flow. And then you can use various types of flows. It depends really on your implementation and your needs, but that's up to you. So that, of course, we can use that class, actually, and we can use an interactor, like we did before with the callback approach. This interactor is able maybe to send events, and of course to receive those events from Bluetooth. And as you can see here, we have another function, the request status function, which this time is a suspending function, because we're using flows, and we can do some magic also with flows, because that's great. And for example, we can translate to a single function all the, let's say, callback style code that Bluetooth GATT usually gives to us. In this case, we are subscribing to the characteristic change events. We are filtering those events, just making sure that they are the response to the command we sent, or maybe to do some other verification. And then the important thing is that once we subscribe to the flow, so in the onStart method, we actually send the command, so that we are already subscribed, we are able to receive the responses, and then we send the event, the command, sorry. And yeah, of course, by relying on the first operator, we can basically translate that reactive flow in a single suspending point, so that we get the result, and we can map it to do something cool, of course, with coroutines, like always. And of course, from a testing perspective, this is quite easy, like the approach before. We can create a fake emitter, which basically drives the values we are meant to receive from Bluetooth. And then once we provide that emitter into the interactor, we can test the responses and do some assertions to check that our code works, actually. So main points here, by using flows, you are like ensure that operations are sequential by design, since they are Kotlin flows, and that's like a manifesto. And we, of course, can minimize the class state because we can try to write code and encapsulate it in functions without, having to hold the state of a response as a class property and stuff like that. Of course, we avoid callback hells. And in general, we improve readability and troubleshooting because the code is easier to read. And so also for code review, that's great. So now we spoke about testing. Okay, we saw quite a bit of unit testing. But now let's see how can we test the device, maybe the device you are interacting with, remotely. Since we are on Android, we can do crazy stuff. Okay, so at Empatica, we were used to test with some machinery that worked like that. This, for example, is testing that the connection to our EmbracePlus, our device, is working properly. And as you can imagine, this is like a human-driven test. There is a human that is putting the pod of the EmbracePlus into the sliding thing, and then it slides into the pipe. And by looking at the UI, basically, we see that something is changing, maybe a disconnection or stuff like that. But then, you know, and everyone knows, the pandemic hits. We went remote. We were not able to do in-person tests like those, and we needed to like invent something. So, from being remote, of course, challenges appeared, and we need to figure out. So basically, we kind of figure out a strategy to test a device remotely, something like that. And we used basically 3 tools. So first, a VPN. And I mean, I think everyone here knows what a VPN is, But in general, we can say that in our case, every MacBook is connected when needed and to a VPN server, and it points to that VPN server, okay? And since we are connecting to a VPN server, it can create a virtual network. So each MacBook can ping another MacBook that maybe, I don't know, is in another part of the world. And of course, try to imagine if you can install those VPN on your Android phone, then you can make like talk your MacBook and your phone. And of course, security is enforced because, it's a VPN, so security engineers are okay with that. And the second tool is the ADB, and everyone knows what it is. So it's the Android Debug Bridge. Basically, a command line tool allows you to communicate with the device, install application, debug them, see the logs, run commands. And it bridges the connectivity no matter the mean. Even using a physical cable or using a TCP connection like over Wi-Fi. Remind this. Then third tool, Visor, is a quite convenient application and allows you to mirror your screen, the screen of your phone, your computer. And of course, it works with ADB. So now let's have a quick look on how to work remotely and ADB like over Wi-Fi. So you can do it with Android Studio, but I will show you how to do it using the shell. Maybe you need to write some scripts, and that's useful. So with the ADB devices command, you can see all the device attached. So maybe you are the person that need to share the device with another one which is remote, and you run this command to understand which is the ID of the device. Then using the ADB TCP IP command, okay, you can provide a port and restart the ADB in your device to listen on that port. Then you need to, of course, discover the IP of your device, and you can run shell commands, and that's great. You can do it like that. And yeah, that's the local IP. And then on the machine of maybe of the developer that needs to connect to the device, you can just run this command, and you are getting connected to that phone. So you on your machine are connected to a remote phone. Of course, for the sake of this example, we use the same machine, but as you can see, we have the first device we had, and the second one, which is connected over IP. This is very powerful if, let's say, coupled with Visor, because with Visor, you can see the screen of other phones, and in this case, we had connected a phone via cable, and after doing this process, we actually can see the other phone that is connected over Wi-Fi. And if you click that wonderful red play button, you can see that a device pop-ups like an emulator, and you can click on that. You can, do everything you want. And of course, since it is connected to the ADB with Android Studio, you can see it actually in your IDE. So you can run apps, see the logs, and do all the troubleshooting you want. In my case, this was really helpful because I was struggling with the integration of Android 12 and 13 in my phone, because I don't have a Pixel, so at the time I didn't have the new system update. But a QA engineer here in Empatica had it. So since I needed to provide the support, and actually I didn't have the phone, I kind of figure out this strategy. So I was able to actually debug the app and test the actual system flows, with the system pop-ups to ask the permission to the user for the new Bluetooth permissions directly on the phone of our QA engineer. So that was really convenient since we are working from home and I didn't have the physical access to that device. And that was really cool. So just to, let's say, end this talk, we need to say something also about Android 12 and 13, because, yeah, with version 12 and 13, Google introduced new features and new kind of permissions, more fine-grained permissions that you can use to control the access of the users on the Bluetooth stack. So first, let's go with some deprecation they did. And yeah, basically, if you worked with Bluetooth, you are used to know the Bluetooth adapter get default adapter method, and forgot this because it got deprecated, so that's it. And instead of it, you can use the good old context, and via using the get system service method, you can get an instance of the Bluetooth manager, and from that you can get the adapter. So that's the new way. I mean, it's not really new, but that's the preferred way to do that now. So the Bluetooth adapter is tied to the context, okay? And then once you have it, you can do whatever you want with it, like we saw in the previous slides. Of course, we mentioned also permissions, and it's worth to say that Google changed quite a bit the permissions that you need to ask for access Bluetooth. So before Android 12, you basically needed to declare this set of permissions. So you had the Bluetooth permission, BLA communication, requesting connection, and stuff like that. The Bluetooth admin connection to initiate the device discovery. And of course, if you do pairing with your device, you need that permission. And also the location permissions, which were not ideal from a user perspective because you're building a Bluetooth application, not like a GPS application. So asking for location permissions were not so cool from a user perspective. But starting with Android 12, new permission arrived. And so to integrate them in our application, basically we started by fixing a maximum version for the permission we already had. So like Bluetooth admin, and the location permission were declared until the API 30 version. And then starting from Android 12, we have the new set of permissions, like the Bluetooth Connect permission. So it's useful if your app communicates with a device. I mean, if you're using Bluetooth, it's likely you're communicating with a device. Of course, the Bluetooth scan permission. And in our case, we did like this assertion, and we are saying that we are scanning without asking for location, because yeah, when you scan Bluetooth devices, you can gather location information in some way. And by doing this assertion, you are safe, and you are telling that, no, you're doing it, you're not doing it. And they added also a new permission, which is the advertised permission if your app makes like the phone discoverable some way. And please remember that those permissions are still runtime permissions. So you still need to ask them at runtime and provide some kind of nice UX to your user to educate them. Last but not least, speaking about methods deprecation, again, we can say that also the write characteristic method has been deprecated, and we saw before like a very bad error, I mean, on the mutability of the value of such characteristic. So once you try to write in some characteristic and maybe the device is writing in the same, you can have a corrupted byte array or stuff like that. And then starting from Android 13, Google introduced a new method deprecating the previous one that allows you basically to specify as an input value the value you are going to write into the characteristic. Because before you had to get the characteristic, mutate the value. So it was like a var in Kotlin, so you can mutate it as you want. And now you can just provide the value into the method and allow the stack to do that for you. So it's more convenient and avoids you maybe threading issues or concurrency and stuff like that. Okay, so now we are at the end of the talk. So if you have any question about the topics we explained, if you were happy to listen to that, we are also happy to answer to your questions. So big thank you for being here. Thank you. And also, I would like to mention a quick thing, because we have a booth here at the Droidcon, so we are doing like a contest. So we have in prize the clean architecture, like the holy Bible of Android developers in some way, and also the Android's book by Chet Hayes. So if you come to the booth, you can participate to the contest and try to win those books, and we are waiting for you. Thank you very much.